What if everything we thought we knew about the beginning of the universe was wrong? The James Webb Telescope has just discovered 15 bizarre galaxies, so ancient, so massive, they may have existed before the Big Bang itself. Something extraordinary is happening in the cosmos. What if the story of our universe, the one we've held for decades, is wrong? What if the Big Bang wasn't the true beginning? The grand narrative is one we all know. A universe born 13.88 billion years ago from a single point, which then expanded and cooled. From this primordial furnace, matter slowly clumped together. Over hundreds of millions of years, the first stars ignited, then gathered into the first infant galaxies, small chaotic collections of light. This has been the bedrock of modern cosmology. But humanity's golden eye on the cosmos, the Webb telescope, was built to confirm this very story. Its mission was to peer back to the cosmic dawn and validate our elegant theories. Instead, it sent back a cosmic wrench. It has found galaxies so massive, so mature, and so ancient, they appear to predate the time they should have had to form. This isn't a small anomaly. It's a discovery that could unravel everything. Are these impossible galaxies a glitch or a glimpse into a reality we never imagined? Before looking into the chaos, we have to understand the order it threatens. The standard model of cosmology, known as lambda CDM, has been incredibly successful. It begins 13.8 billion years ago with the Big Bang. Think of it less like an explosion and more like a loaf of raisin bread rising in an oven. The dough is space itself, and as it expands, the raisins or galaxies are all carried away from each other. For the next 380,000 years, the universe was a quiet, dark, simple place. The cosmic dark ages. It was a fog of neutral hydrogen gas without a single star. Then, according to the lambda CDM model, gravity, with the help of a mysterious substance we call dark matter, began a patient bottom-up process. It was like building a Lego castle, one tiny brick at a time. It slowly pulled the densest regions of this gas together, like steam condensing on a cold window. The first stars, called population 3 stars, ignited around 100 to 200 million years after the Big Bang. They were behemoths that lived fast and died young, seeding the universe with the first heavy elements. From their ashes, the first proto-galaxies were born. Astronomers expected these to be small and misshapen. The grand spirals we see today, like our Milky Way, were thought to be the product of billions of years of mergers. To see this process in action, we built the Webb telescope. Its giant gold-plated mirror is designed to capture the faint red-shifted light from those first galaxies. This red shift is like the sound of an ambulance siren. As it moves away, the pitch gets lower. For light, moving away stretches its wavelength, making it appear redder. The higher the red shift, the farther back in time we look. The Webb telescope wasn't just built to take beautiful pictures. It was built to find those faint flickers and confirm our story of creation. But what it found was something else entirely. Within weeks of operation, the Webb telescope data began pouring in, and astronomers noticed something deeply unsettling. Staring into an era just 300 to 500 million years after the Big Bang, it wasn't finding the infant galaxies it expected. It wasn't finding the Lego bricks. It was finding the fully built castles. Instead, it found monsters. Surveys like the Webb Telescope Advanced Deep Extragalactic Survey, or JADES, began identifying several galaxies at extreme distances that were informally nicknamed universe breakers. Found when the universe was only 500 to 700 million years old, they appeared to have stellar masses up to 100 billion times that of our Sun, on par with the modern-day Milky Way. One astronomer said he nearly spit out his coffee, stating, "We just discovered the impossible." And then the discoveries kept coming. In early 2025, astronomers confirmed JADES GSZ 140, a galaxy seen as it was less than 300 million years after the Big Bang. Not only was it stunningly bright, but a detailed analysis revealed a significant amount of oxygen. Oxygen isn't made in the Big Bang. It's forged in the hearts of massive stars that must live and die. Finding it so early is like finding a fully baked multi-layered cake just moments after the first seeds of wheat were planted. It means generations of stars must have already lived and died. Then in May 2025, the Webb telescope broke its own record, confirming a galaxy named MOM-Z14. Its light comes from just 280 million years after the Big Bang. Like the others, it was bafflingly luminous. The team concluded its brightness wasn't from a central black hole, but from the sheer number of young stars it was furiously producing. Here's the twist. This isn't like finding a surprisingly tall toddler. It's the cosmic equivalent of exploring the first hominid settlement and finding a skyscraper with the lights on. The standard model simply doesn't allow enough time for these structures to exist. They are too big, too bright, and too structured. It's a paradox staring us in the face. How is it possible? Well, the discovery of these impossible galaxies has ignited one of the most ferocious scientific debates in a generation, splitting the community into two camps. This isn't a sign that science is broken. It's a sign it's working. On one side are the revolutionaries. They see the data from galaxies like Jade's GSC 140 and argue that the lambda CDM model, our standard model, is simply broken. Its core assumption is that galaxies grow from small to big over billions of years. The existence of these massive mature galaxies just a few 100 million years after the Big Bang directly contradicts that. Some have taken this to a sensational conclusion that these galaxies must have existed before the Big Bang. Let's be clear, this is a profound misinterpretation. The extreme red shifts of these galaxies definitively place them hundreds of millions of years after the Big Bang. What they challenge is not the event of the Big Bang itself, but the timeline of what happened after. A more serious challenge comes from proponents of alternative gravity theories like modified Newtonian dynamics or MAND. They argue we don't need dark matter. To them, dark matter is like inventing an invisible cosmic wind to explain why a ship is moving so fast when perhaps the ocean currents, the laws of gravity themselves, are just stronger than we thought on those scales. They claim their theory predicted this rapid formation of large structures. On the other side are the defenders of the standard model, where the majority of consensus currently lies. They argue that while the findings are shocking, they don't require us to throw out the entire Big Bang framework. Instead, the problem is with the fine print details of early universe physics. The Big Bang still explains the vast majority of cosmic observations. These early galaxies aren't universe breakers. They are assumption breakers. Now, this camp is scrambling to figure out what fundamental processes we've misunderstood. Perhaps the first stars were more massive and efficient than we thought. Maybe gas in the early universe could cool and collapse far more rapidly. Or, and this is a tantalizing idea, their formation was kick-started by something else entirely, primordial black holes. This debate is far from over. Does the standard model bend, or does it break? Either way, our understanding is on the verge of a radical transformation. If the standard model is to survive, it must adapt. Scientists are now exploring new physics that could explain how the universe built these titans in record time. One leading idea is that star formation was hyper-efficient in the early universe. Today, the process is relatively slow and messy, but the early universe was denser and composed almost entirely of pristine hydrogen and helium. New models propose that under these conditions, star formation was less like construction and more like 3D printing, allowing gas to collapse directly into massive star-forming clumps at a blistering pace. Another possibility involves feedback. When massive stars are born, they pump out huge amounts of energy. In the modern universe, this often blows away gas, shutting down star formation. But scientists now theorize that in the primordial darkness, this feedback might have worked like a positive chain reaction. It's as if the heat from the first burning tree in a forest, instead of creating a clearing, instantly caused all the other trees around it to ignite. Perhaps the most compelling idea involves primordial black holes. We think of black holes as the end state of massive stars. But what if a different type formed directly from the collapse of dense matter in the first second after the Big Bang? If they existed, these primordial black holes would act as gravitational seeds. While gas would have been pulled together slowly on its own, these pre-existing black holes would have been cosmic magnets, rapidly pulling in vast amounts of gas and accelerating the formation of the first stars and galaxies around them. It could be that the galaxy didn't form the black hole, but the black hole formed the galaxy. This would neatly explain both the size and maturity of these impossible structures. While most scientists work to fit these discoveries into the Big Bang framework, the sheer strangeness of the findings has revived more radical theories. These ideas live on the fringes, but the current crisis has brought them back into the conversation. One of the most prominent is the Big Bounce. This theory suggests our Big Bang was not the beginning, but a transition point in an eternal cycle of expansion and contraction, like a cosmic lung breathing in and out. In this model, a previous universe collapsed, bounced, and re-emerged as our own. If true, the massive galaxies seen by the Webb telescope might not be new creations, but ancient relics that survived the cosmic rebirth. Another idea is plasma cosmology. Proponents argue that electromagnetic forces, not just gravity, played the dominant role in shaping the universe. They see the cosmos as an intricate web of cosmic electrical currents and magnetic fields, which could explain the complex structures seen by the Webb telescope without the need for dark matter. Some physicists have even proposed that to solve the Webb telescope paradox, the universe might be twice as old as we think, 26.7 billion years instead of 13.8 billion. It is crucial to emphasize these models remain highly speculative. They lack the overwhelming support that underpins the standard Big Bang model. However, they highlight the profound nature of the questions the Webb telescope has forced upon us. The Webb telescope was sent to look at the birth of the universe, expecting a quiet cosmic nursery. Instead, it found a cosmic metropolis bustling with giant galaxies that have no right to exist. So, are there galaxies older than the Big Bang? The answer is no, but the reality is far more interesting. We have discovered galaxies that are far too old for their time, structures that challenge the very pace of cosmic evolution. The impossible galaxies have shown us that our neat story of creation was too simple. The early universe was not a quiet nursery. It was a frantic factory building massive structures with an efficiency we are only now beginning to comprehend. This is not a failure of science. It is its greatest triumph. We built a machine capable of breaking our most cherished theories. The Webb telescope hasn't broken the universe. It has shattered our complacent understanding of it, replacing a simple story with a profound mystery. And the most thrilling part, the journey is just getting started. If you thought the universe had a clear beginning, surprise, it might have had prequel episodes. Hit subscribe before these ancient galaxies sue us for spoilers. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. What do you think? Could Trappist we be home to life? Or are we chasing a cosmic merge? Thanks for watching, and we'll see you in the next.